This is example 2 on simplifying radicals. For this example, we have this expression inside of a cube root. And what I want to do is simplify it. Now I'm going to show you the long way to do it, and then I'm going to show you the short way to do it. The long way will help you understand why the short way works, okay? So what I like to start doing, although this is not necessary, some people don't need to do this step. I like to rewrite this expression in individual radicals. Since I'm multiplying these factors, I have 3 factors here. I have 8, I have x to the 6th power, and y to the 4th power. They're being multiplied. I can separate them into their individual radicals like this. And they're all cubed roots. Okay? That's what I like to do first. And then after that, I start evaluating or simplifying if I can. For my first one here, I can say that the cube root of 8, this is equal to 2. For this one here, I can rewrite the cube root of x to the 6th power as x to the 3rd power times x to the 3rd power inside the radical. And this is equivalent to x to the 6th power, right? Because if I multiply the same base, I can add the exponents. So all I've done is I separated these two into powers of 3. Why powers of 3? I did powers of 3 because my index is 3. And if I can match this index, then it's easy for you to see that I can cancel these terms. Okay, I can cancel the exponents. The same thing I'm going to do with this other factor. I'm going to rewrite y to the 4th power as y to the 3rd power times y. And again, I try to match my index, okay? And y to the 3rd power times y is the same thing as y to the 4th power. And now I can break this up even more. This is 2. I can separate these two factors into their own radicals since they're being multiplied. And the same thing here. All I did was separate these and put them into their separate little radicals. Again, this isn't necessary. It's just to show you how we get to our answer the long way. Now I have the cube root of x cubed, and this is equal to x. And let me show you why. I'm going to come off to the side here. The cubed root of x cubed, if I were to rewrite this as a rational exponent, this would look like this. Right? The exponent is your numerator and the index is your denominator. This is what this would look like as a rational exponent. And this is equivalent to x to the 1st power, which is x. So that means that x, the cube root of x cubed is x. So for each cube root of x cubed I have here, I get an x. So this is 2. Here I have an x. Here I have another x. And the same thing happens when I have y cubed, the cubed root of y cubed, the same thing. If I change this to a rational exponent, this is how this would look. And that equals y to the 1st power, which is y. So this here is equal to y. And here it is, y. And then the cubed root of y, that's just y to the 1/3 power, which means you just keep the cube root of y because you can't simplify that. You would need y squared. And now let's gather these terms. 2 times x is x squared times y times the cube root of y. And this is the final answer for this problem. Now this is the long way. That's the long way to do it. The short way, I'm going to do down here. The short way would be the cubed root of 8x to the 6th power y to the 4th power. Here's the short way. I wouldn't separate these into their own radicals like I did here. I would just work within this radical, okay? So I would look at the 8 first, and I would say cubed root of 8, that's 2. And now I have x to the 6th power. What I do is I take this 6 and I divide it by the index. So I have 6 divided by 3, that equals 2. That 2 is the exponent of this variable that I'm going to have outside of the radical. So I know I'll have an x, and the exponent will be the division of this exponent with this index. 6 divided by 3, 2. I do the same thing with y. I take my y, I look at the exponent, it has a 4, I divide 4 divided by 3. Now look at what happens when I divide 4 into 3. 3 fits into 4 once. This 1 becomes the exponent of y outside of the radical, y to the 1st power. And I also have a remainder of 1. This remainder is the exponent of the y that stays inside the radical. And that's the short way to do it. I'm going to go over this again. I take my exponent and I divide by the index. 6 divided by 3 is 2. That's the exponent of the x that's going to come out of the radical sign. Since I don't have a remainder, that means no x remains inside the radical. For y, I get 4 divided by 3, which is 1. That's the exponent of the y that comes out of the radical. And since I have a remainder of 1, then this remainder tells me I have a remaining y that remains inside of the radical, and the exponent is 1. So there it is, exponent 1. And when I write this to look prettier, because we cannot have y to the 1st power. Y to the 1st power is just y. And now it looks pretty. And this is your final answer. So you have the long way, doing this, and you have the short way. I hope you understand this example. If you don't, go back, watch it again, pause, go back, etc. Have fun.